All right, so let's say that we have ourselves an x-axis and a y-axis. All right, I'm just calling this x and y. They can be anything. You know this already, but that just for this particular experiment, let's call it x and y. So that means that this particular point is our the only point that's under consideration right now. It's going to be x and y. Okay. So we're considering one single point. So how do we look at this in terms of trigonometric functions? Well, this is the way we're going to do it. Let's just choose this color here. We're going to call this our y-axis, and let's choose this color here, and let's call this our x-axis. I'm thinking you guys can see all of that. This is our x-axis here, and our y-axis is right here. Okay, so we know that this is y, we know that this is x. And when I speak about y and x in these particular terms, we are talking about the actual length, okay? Using some rule over here, some kind of ruler. And we also have some kind of length here. And even though they're on the x-axis, we're using the same letters, but we're now moving to the idea that we have ourselves a number, okay? So x and y, we know those values, so that means that we can determine r. And r happens to be the longest side in this triangle. It happens to be opposite the longest angle, so we refer to this as the hypotenuse, okay? Hypotenuse. And if we are trying to determine an angle, well, if we define an angle in this triangle, then the side that's opposite this angle is called the opposite side. And the side that's right next to this angle is called the adjacent side. Okay? And so x is the adjacent, y is the opposite. This is our right triangle. This is what we pretty much know this. So that means that we can form all kinds of trigonometric functions from this. There are two primary ones that I want you to know, but I want to show you that you can develop 4 more by understanding those 2. So the first one is sine of the angle theta, and it's just the opposite over the adjacent. That's not true. It's the opposite over hypotenuse. Okay? And then you have cosine. And I had better write these legibly. Cosine of the angle, and this is the adjacent side over the hypotenuse. All right? So that means that all we need to know are the values for y, and this y happens to be this distance over here, this length, this orange vector, the length of the orange vector divided by the hypotenuse. In this particular case, it's the length. In every other particular case, it's the length of the longest side. So it's y over r. The adjacent side happens to be x. So it's the yellow vector, the length of the yellow vector, or the magnitude. What's more appropriate, probably more general, is the magnitude, because it doesn't just have to be displacement or length, it can be other things. And so this is going to be x over r, okay? And I can just go ahead and say, well, I could put down tan. Tangent of theta just happens to be sine of theta over cosine of theta, which just ends up being y over x. Okay, so there are 2 ways to determine tan of theta. You can do it both these, I mean, you can do it either one of these ways. So once you've determined sine and cosine, tan of x can be determined in terms of sine over cosine, or y over x. You know what? This is the unit circle. I only need to mention those 3 trigonometric functions. This is a theory. This is what we're going to put in Microsoft Excel. Okay, we're going to collect data about not only this point, but quite a few points, probably 150 or so. So it's going to go around like so. So I can keep putting points here. I'm going to collect all of this data. And when I collect all of this data, as you will as well, to collect all of this data, we're going to apply R, and I did not write down what R is. So we're going to use Pythagorean's theorem for R. So let me just write it up here at the top. This is going to be equal to x squared plus y squared. So that's Pythagorean's theorem. And once we have R, based on x and y, we can find sine, cosine, tangent, and other trigonometric functions. But we're going to take this point. We're not going to only stay with that one. We're going to keep going all the way around. We're going to make a complete circle. And once we make that complete circle, I'm going to take that data over to Microsoft Excel. I'm being redundant, so I'm going to stop right there. And I'll see you in the next video.